All right, our first problem is a GeoGebra problem. It wants us to write a rational function Rx such that the value of r of -1 is undefined. The limit as we approach -1 is equal to 1, and the limit as we approach -3 is equal to positive infinity. Okay, so you need to recall properties of transformations and what causes holes and undefined values in the graph. So I'm going to start with some of the less challenging parts. So the first one wants us to have the value r of -1 to be undefined. Okay, so what that means is on a graph, and the point could be anywhere, but at -1, if my graph is curving or there's a line, there will be a hole at -1, whatever our graph looks like. The way we cause a hole is by dividing out a value in the top and the bottom. So when the x value goes to the left, we have to write that as an x plus 1 term. Okay, so when we graph or when we write the equation of this function, we're going to need to have an x plus 1. Okay, so what that means is when I plug in a -1, the bottom goes to 0. And so I would need to have that same value on the top, or that same term on the top, x plus 1. So that means if I plug in a -1, this term gets canceled out, but it causes a hole. Okay, so that first condition will be satisfied. Now, as far as the limit is concerned, we can't evaluate the limit until we have the rest of the function. So I'm going to have to skip over this one and then start with this one. So we want the limit as we go to -3 to be positive infinity. Okay, so we need, again, another rational function. If you think about the function 1 over x, okay, if you were to graph that, you'd have an asymptote or a undefined line at 0. But the limit is not positive infinity or negative infinity because both sides don't go the same way. So what we need is the graph of 1 over x squared. Okay, the graph of 1 over x squared, okay, will take both ends going up. So the limit of this graph as x goes to 0 would be positive infinity. However, we wanted that to happen at -3. So I just need to shift this graph over 3. So using the property of transformation, if we do x plus 3, and again, that's because when you plug in x minus 3 or -3, that's when it happens, and we take this function squared, this will give us the function that will shift this over and give us an asymptote or infinity, a limit of infinity as we go to -3. So on the denominator, we're going to need to add x plus 3 squared. Okay, so this takes care of two conditions. This gives us undefined value at 1, and this also gives us a limit as we go toward -3 to be infinity. The last condition we need to satisfy is the limit as we plug in -1. We want that to be equal to 1. So all we need to do is apply some kind of transformation to this graph to make sure that happens. So let's simplify. So if I was working this graph and then trying to do the limit, so I'm going to do limit as x goes to -1. And so what's going to happen, I'm going to divide this out because that's going to cancel out each other. And that's going to leave me with 1 over x plus 3 squared. And we want this to equal 1, but let's find out what it actually is equal to. And then we'll write or add or shift to make it work out. So if I plug in a -1 here, that will give us 1 over -1 plus 3 squared. 1 take away, well, 3 take away 1 is going to give us 2. We square this. This gives us 1 over 4. So right now, our limit is 1 over 4, but we want it to equal to 1. So what do we need to do to make this equal to 1? Well, we need to add 3 over 4. Okay. if we add 3 over 4, or if you actually just subtract that, that'll give you the same thing. If I take the 1/4 and I subtract 1 over 4 from both sides, that's another way of looking at it, to actually solve it mathematically. 1 minus 1 over 4, that will, you need to write a common denominator, so I put 1 over 1, and then that would be times 4 and times 4, so I have 4 over 4, and you subtract 1 over 4, that gives you 3 over 4. So the better you are with algebra, the better you can come up with that a little bit faster. But anyway, the end goal is we need to add 3 over 4 to this function, and that will make the limit be equal to 1. So I'm going to go back to this function. I'm going to say plus 3 over 4. Okay, so this is the function that we need. However, when you go to plug this in, they want you to combine these two. This isn't a rational function because you have this separate term out. So we need to combine these two terms together. I'm going to go to the next page because I'm running out of room, but I'm going to start here. So okay, so we have x plus 1, and then we have another x plus 1, and then we have x plus 3 squared, and we have to add a 3 over 4. So in order to combine fractions, we got to get a common denominator. So the easy way to do that is you can multiply these two denominators together. That's going to give you the common denominator, and you just pretty much cross the tops. So I'm going to multiply this. It's like multiplying this whole thing top and bottom, and 4 top and bottom over here, but a shortcut, you can just multiply the two bottoms together. So I'll have a common denominator by just multiplying a 4 out front, and then giving me x plus 1, and then the x plus 3 squared. So that's my common denominator. Now if I multiply the 4 over here, that will give me 4 times x plus 1. And then if I multiply this whole thing times 3, that's going to give me a plus 3 times the x plus 1 and times the x plus 3 squared. So this whole thing will give me a function that satisfies all of the requirements, that has an undefined value at 1, that has a limit that goes to positive infinity as we approach -3, and the limit of this function as we approach -1 will be equal to 1. And since it's all one term, it's a rational function. So I'm going to plug all of this in. And then on the bottom, 4x and x plus 3, and that needs to be squared. Okay. All right, so you see we got correct, and it goes over everything, and it just shows you one possible solution. So what they've done is they've just kind of simplified a little bit more algebraically to kind of bust some of this up, but most of it's going to be the same. But if you can do that, remembering transformations, you'll be able to work that one out just fine.